Hello and welcome to another video. Today I'm going to explain the systems of the jet kart, how it's all plumbed up, how it goes together, how the electronics and the ECU works, which is all new. So here we go. Okay, so to start the engine I need compressed air from a scuba tank, and that now comes in here on this hydraulic QD. You can see that the pipe is saddled up. And basically this black pipe comes into the engine to impinge on the compressor. Also here at the back I've got the drain when I start the engine to make sure there's no fuel pooling up. So again, that's on a QD, and that comes to the bottom of the engine. Moving on to oil. So I've got this lovely new oil tank which I've described before. The setup is as simple as possible, even though it looks complicated. So basically, the bottom of the oil tank, there's a feed to this hydraulic pump. So the pump is the same as before, but I've got a new, more powerful brushless motor powering that. And then basically the pump sends oil to the cooler, which you can see under there. And then it comes out of the cooler into this oil filter housing where I'll measure temperature and pressure, and then it comes up and into the engine, and then it returns back to the tank through that bigger line underneath here. All of these lines really expensive. I think this fitting here that you can see, just that one black fitting was 20 quid. So obviously you multiply it through by the numbers of fittings, pipes everywhere, it really starts to mount up, but yeah, it had to be done. There's another little thing here, which is that I had to fit a small running bleed to the oil system, because when I start the engine with cold oil, it was just building too much pressure and stalling the pump. So yeah, that running bleed is saddled on the top of the tank, and then just returns into the bottom of the tank just to bleed a little bit of pressure off. Now, in terms of blow-by from the engine, with which there's a varying amount, basically the oil will foam up and de-aerate in the tank, and then this line at the top of the tank allows the gas to come up, and that goes into this catch tank here, which has a foam filter for the air to escape. This catch tank here makes it swirl, and so yeah, that's to basically get all of the air and oil separated out, and then any oil that does separate out returns to the tank via that clear hose which comes into the bottom of the tank, and that also is my sight tube, so it's basically recirculating so that I don't just lose any oil out of the breathing, basically. So fuel system, obviously I've got twin tanks as I've described before, and these link together in this welded up manifold here, so they join and then they go to the fuel pumps via this dash line. There is a gauze filter in there as well, just to stop any big bits getting through, and then it joins to this T-piece, and there I've got my two fuel pumps. So this is the pump for the main engine. That's a brand new Bosch 044, which can deliver 10 bar. That goes to a filter, and then that feeds into the engine. So then I've got this second pump here, which is the afterburner fuel pump. Again, it's a Bosch 044, but it's the old one that I had on there before. And then this pipe here feeds the afterburner. Also on the fuel tanks, there's breather on both of them, which are the sort of clear line here that you can see running back. And this just comes up to the top, both of those, so that, yeah, they can breathe. So in terms of the general layout of the electronics, I have got here my ECU tucked in here, and that is basically the circuit boards. There's two switches which controls the starting, and there's a couple of potentiometers. Then I've got my digital dash. On the steering wheel I've got a kill switch and a lanyard, and I've got the afterburner button. And this ECU is then loomed through this large bundle into my new power box. So this is basically where I perform all of the kind of splitting out of relays. I've got a new VESC in there which controls the oil pump. I've got the relays you can see in there. Got my high side drive circuit boards, new battery, contactor, which is killed by the kill switch here, and there's also a battery cut-off kill in the side. I've got the pressure sensors for the ECU here, which is for measuring the total pressure in the tailpipe, obviously the boost pressure of the engine, the fuel pressure and the oil pressure. So they're those 4 sensors on the side, which are loomed back into this main loom. Here I've got all of the connections to the power box. Now I use these amp seal cheap automotive waterproof connectors. I couldn't find them in a bulkhead mount, so everywhere that you see them, you can see that I've had to 3D print something to go around the connector and turn them into a bulkhead. But yeah, all of the wiring's labelled. It's all sort of neatly saddled. So got some fairly elaborate 3D printed saddles. I have put a massive amount of effort into saddling everything, which is where you could, there's sort of dozens of nice little saddles all over the KART for everything. And I've also got like anti-chafe wrap for anywhere that isn't saddled. So yeah, fingers crossed that gives me a nice reliable system. Here it's big saddle, goes into ECU. I've got a throttle pedal here, which obviously gives me a 5-volt signal. Yeah, that's mounted up on the front here, also goes into the ECU. Back here on the left, I've got my new ignition boxes. So this big one here is the main engine box, got a microwave capacitor, a spark gap and a diode, and that is all potted with compound so that nothing moves, but also that compound which is covering the spark gap means that I'm not going to get any EMC, or a lot less, because the spark gap is the main cause of that. I've got my little high voltage generators in here, which then join up inside there. I've got my second less complicated ignition box for the afterburner spark plug, which again you can see there, everything's all nicely neatly saddled. Here is the connection for the afterburner spark plug, which is heat wrapped, so hopefully decent. Here I am using a normal spark plug for an automotive engine, which is much easier and cheaper to get hold of than the aircraft type. And yeah, that I have machined the end down to be a nice fit. This is a surface discharge spark plug, similar to a pucker aircraft type, but a lot easier to interface with a normal connector, normal metric thread, and then that joins up with a flame tube. Temperature measurements, I've got 3. I'm measuring the turbine outlet temperature via this thermocouple, which is obviously massively important for making sure the engine is not going to melt. I've got obviously the oil, which we discussed, and I've also got compressor outlet temperature, which again, making sure that my compressor is within bounds. Now all of those are routed back to here, another 3D printed saddle, all nicely labelled up, going to the main loom. Now onto the ECU. This is my 5th generation of ECU since I started making them for the jet bike, which was really helpful for learning all of this stuff. Now I've designed this on the PC. You can see the schematic here, and the PCB layout, and the packaging in KART. Now I use an Arduino Mega, which is cheap, about 20 quid, as the brain of the ECU. I've worked out all the I/O that I needed before I designed this, and then I have created the PCB. Here is the first one that I designed, which never even got built or used. This one was going to have data logging on it for an SD card, but I figured out that that wasn't as useful to me as a speedo, and I needed to basically release another one. So this has got GPS module in it now, here, which communicates and gives me speed readout. I've got, obviously the pressure sensors, the thermocouples, which go through these little interface boards on the side. These two potentiometers, which I can access. One is for setting the idle, engine idle fueling, and the other one is for setting the afterburner fueling ratio. And then the rest of it is obviously, outputs for relays, PWM for pumps, and all the other bits and pieces, switches, etc. that I need. So that communicates with the dash to give me my readouts. And I'll turn the dash on now so that you can have a look at that. So flick the switch, it fires up, and now you can see my display. Now I designed this also obviously on CAD after 3D scanning the steering wheel. I've got oil pressure on the top left, I've got fuel pressure on the top right, I've got the two numbers at the top which determine basically these pot reading. Compressor temperature there which says T2, the total pressure of the turbine outlet. I've got battery voltage so I can see how much juice I've got left on my boost, oil temperature, turbine outlet temperature, which is highly critical, and then the throttle pedal. Now in terms of the speed, which is currently reading nearly 1,000 miles an hour, once the GPS, which gets satellite tracking, which it will do in a minute or so, that will start to read correctly. I've had to open a garage door for it to pick up the satellite, but it's blinking away, you can just about see that, and I've now got speedo, happy days. So moving on to the power box, this replaces the old relay box, which was a bit of a bird's nest, and here I've got fuses on the top for different bits and pieces, pumps, fan, igniters. I've got a main fuse in here. I've got the new VESC, which controls the oil pump, which I've mentioned. Distribution blocks, it's pretty tight. Isolated relays. Now, the red circuit boards underneath the fuses are these high side drives. They used to be on the jet bike, on the main ECU circuit boards, which you can see here, these big heat sinks. I had a few problems with them failing, and I wanted to make sure that if it did fail, I didn't need to build a whole other ECU because it's really expensive. So I've separated those out into these little boards, which I can replace a lot easier. However, I do think I've figured out why they were blowing up anyway. So hopefully that's all good now. So now that we know all the different bits, it's time to talk about what the ECU does and how it works. So design this to be as simple as possible to operate. So basically it has an automated engine start routine. Firstly, it goes into pre-start, which basically builds oil pressure and just waits for command to start. When you give it the command to start, it's going to ramp the fueling to the engine to the amount which is set by the idle pot, and it's going to spark the main plug at the same time. If it does not see boost pressure within 20 seconds, it will self-abort the start. If it does see boost pressure, it will move into running state, where I've got full control of fueling and it can afterburn and do all the other bits and pieces. So the oil pressure is controlled to normally be about 2.5 bar at idle, and once the engine boosts, the oil pressure will automatically aim to be 1 bar above boost pressure. The fuel pressure is obviously affected by the throttle pedal. The throttle pedal reading is heavily filtered, so if I push the pedal up to 100%, and you can see here, I'll let it go now and it slowly reduces. That's obviously because jet engines don't like rapid changes in throttle. The engine can go out otherwise. Oil temperature, so the ECU obviously will attempt to cool the oil if it goes beyond the preset value. So I've got PWM control of the fans, and that will self-regulate oil temperature. The ECU does check the critical sensors when you turn it on, so if anything's not reading a normal value, when you first turn it on, it will refuse to do anything and tell you that you've got a sensor problem. I think, that's pretty much it. So if I flick it on, it will go into pre-start, and you can see the oil pressure's built there. Pump's turning away. Desk is obviously powering that. And then if I was to hit the button, it will start trying to fire the engine up, which I'm not going to do in the garage at the minute. But yeah, I'll turn that off. Goes back to ready. And then that's kind of it really. There's an automated cool down. It'll keep the oil pressure on the engine even after you turn the engine off, so that it can spool down with some oil pressure, so I don't run the bearings dry, which is just a nice to have really. And once it's started, if I hit the afterburner button, it will fuel the afterburner, which is ratioed according to boost pressure, and that ratio I control on this pot here, and it will automatically spark the afterburner spark plug for 5 seconds. If you don't get ignition within 5 seconds, then you need to try again. So hopefully that was a reasonable explanation of the different bits and pieces that should make this kart work. In my next video, I'm going to fire the kart up on all the new bits and pieces, a new engine, and fingers crossed that goes all right. So yeah, thanks for watching. See you in a bit.